Assalamualaikum to our lecturer, TS Dr. Muhammad Haidi bin Maslan. My name is Hiswan Shah bin Hanapi, and this is the list of our group members: Muhammad Nazri Hassan bin Zainul, Muhammad Syafiq bin Bakri, Muhammad Abdullah bin Sabah, and Devin Ibn Anak Adrin. This is an assignment presentation entitled Vapor Absorption System for Ship Air Conditioning System.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Abdullah bin Sabah. Now I will present about the introduction on the vapor absorption system. Okay. The first point is this technology was invented by Ferdinand de Care as early as 1890. Okay. However, it took back to sit during the cheap electricity years and has now made a comeback due to the emerging critical power scenario caused by the depletion of fossil fuels. Okay. Next is the electricity board. It shall limit the maximum load that can be drawn by the customers from the grid at a time based on the availability of power. Okay. And lastly, it is more suitable for air conditioning than refrigerant. And the machine using this technology is commonly called vapor absorption machine, which is BMM. Okay. That's all for me. Next, my group member will continue about our presentation. Thank you.
Now I will present about introduction on ship system. Heat exchanger is an equipment which reduces the temperature of a medium by transferring temperature of that medium to another when both of medium are separated by solid membrane or wall-like structure. For efficient operation, the surface of the wall which separate the two medium are maximized, simultaneously minimizing the flow resistance of the fluid exchanging of heat in a heat exchanger can in between liquid and liquid, gas and liquid, liquid and gas. For heat transfer, basically three patterns of flow are used of construction of heat exchange. Opposite flow is a primary medium and secondary medium which is cooling the primary medium enters in the heat exchanger in the opposite direction to each other. For the cross flow is a primary and secondary medium enters in an exchanger perpendicular to each other. Parallel flow is primary and secondary medium both enter the heat exchanger parallel to each other. Each and every system in a ship is interlinked with each other in some ways or other. Heat exchanger plays an important role for efficient working of different systems, which include the first one is propulsion plant, auxiliary power generation system, starting a system, fuel injection system, refrigeration system, AC system, freshwater system, and steam turbine unit.
Next, I will explain about the estimate amount of heat could be used for the vapor absorption system. The reason absorption cooling requires heat because the absorption cooling involves dissolving a vapor in a liquid and pumping the solution to a higher pressure in the regenerator and finally evaporating the refrigerant vapor from the solution using heat. Lithium bromide is the absorber in the most typical absorption cycle, which implies water as the refrigerant. Next, for operating temperature, in a vapor absorption machine with a single effect, the optimal generating temperature is approximately 200 Fahrenheit. And for low pressure steam, 15 to 20 psig is the most prevalent source of heat. For hot water, at least 180 Fahrenheit may also be utilized. In double effect vapor absorption machine, the needed temperature at the generator is around 370 Fahrenheit. Hence, when employing the process exhaust from a gas turbine or diesel generator, the temperature should normally be greater than 550 Fahrenheit. Next, efficiencies of vapor absorption machine. Absorption chiller efficiency are measured by the coefficient of performance COP, which is the cooling effect in BTU divided by the net heat input in BTU. This figure shows the formula for COP cooling and COP heating. Next, for required amount of heat source. The required heat source temperature is usually above 80 Celsius for single effect machine, and the COP is the range of 0.6 to 0.7. And the required heat source temperature is usually 127.5 Celsius to 150 Celsius for double effect machine. And for the COP in double effect system is 40% higher than conventional single effect.
Alright, now we will discuss about the schematic diagram of the ship vapor absorption system. The system will use lithium bromide, LiBr, as the absorbent, and then H2O, which is water, as the refrigerant. And then this system have the same evaporator and condenser, which is same with the normal refrigeration cycle. And then will not have any compressor, but have absorber and generator. Right, this is the schematic diagram for vapor absorption system. Firstly, low pressure temperature of H2O will move in the evaporator, and then the evaporator need to evaporize the H2O. So the heat from the ship, which is from the combustion engine, with high temperature will move to the evaporator and leave with low temperature. And then the vaporize of the H2O will move to the absorber. So in the absorber, we have the lithium bromide solution and H2O solution, and then it will pump up to the generator using a pump. So lithium bromide is the hydroscopic, which is it can mix easily with the H2O. And then in the generator, we need to supply of heat to make the solution of LiBr and H2O to become the H2O vapor only, because we don't need any LiBr, lithium bromide, in the condenser and evaporator. We only need H2O vapor only. So high pressure temperature of H2O vapor will move to the condenser, and then condenser will convert the H2O vapor to the liquid H2O, and then pump will move the liquid H2O to the expansion valve, and then expansion valve will reduce the pressure of the H2O because it's from pump, and then will become low pressure temperature of H2O, and then it will move again to the evaporator. So as we can see here, this part is function to move the lithium bromide solution from the generator to the absorber. Alright, that's all. Thank you.
Hi, Assalamualaikum. My name is Ahmad Nazir Sam Zainul. Today I'm going to present about conclusion. A vapor absorption system utilizes the lower grade form of a heat energy to produce a cool. So that means absorption system have a low COP, where the vapor compression system need work energy to produce a cool, which is a higher grade form of energy and expensive to produce. So compression system have a higher COP. The compressor of the vapor compression refrigeration system is replaced by the use of an absorber, pump and generator. This system consists of the condenser, expansion device and evaporator, with absorber, pump and generator as a replacement of the compressor of the vapor compression refrigeration system. That's all for my team. Thank you.